And this lesson applies to either the grade 11 course. If you've been in my class before, you've done these methods before and you've followed the exact same strategies before, this is all review. But it does take time to go through these examples. We are adding vectors in 2D, and we're going to do the same example. I'm going to do it once using x and y components and the second time using laws of sines and cosines. In grade 11, I didn't emphasize this method, the second method, but in grade 12, I expect you to be, again, fluent in both methods. Okay? So let's look at the example. We're first going to do it using x and y components, and in the next video, we'll do it using sines and cosines. This here you should have. You don't need to copy this, of course, because you should have it in front of you. And when I add in 2D using x and y components, this is the steps. I'm going to list step 1, 2, 3 all the way through. So here's my example question. First, I want to add two vectors. One is 10 meters north, 30 degrees east, and add this vector to it, 40 degrees west of north. So I want to find d1 plus d2. So the first thing I'm going to do, even though it's not really that relevant if you're adding by components, is I'm going to draw it. I'm going to draw this situation, and this really does lead us to wanting to solve it using sines and cosines, and I totally get that, but you need to learn both methods. But the change in this d is equal to d1 plus d2. So I wrote d1 plus d2, but these two mean the same thing, and it's also called the resultant vector. And so to see what I've done here to draw it, I've sort of drawn d1, and with this would be about 30 degrees, right? North, 30 degrees east. And then I draw another little set of axes and draw my 20 meters, 40 degrees west and north. And this gives me an idea of what I'm looking for. And I'm going to come back to this picture right here when I look for my solution at the end. So the question, of course, is just the type right here when I'm moving around. That's the question. This is me starting the solution by just writing out what I think it should look like, or drawing out what I think it should look like. Okay? So going through the 12-step program, step number 1 is decide what you want to be positive, and it's very important that you know that there's no wrong answer to this. You just decide, and it sort of affects the process, but your final answer does not change. No matter what you call positive, you'll get the same answer. Okay? So if you called south and west, you get the same thing. But I called north and east. Step 2 is to draw the vectors. So d1 and d2. Sort of know where your angles are. So remember that d1 is 10 meters, 30 degrees east of north. And that's why the 30 degrees goes in here. And this is west of north, so that's why the 40 degrees is right there. So it's sort of between this north axis and my vector for each one. Likely I'm going too fast, so I do encourage you to pause. Moving on with the program, the 12-step program here. Step number 3, 4, and 5 are all about finding the horizontal and vertical components. What that means is, if you don't recall from last year, is you take your original vector, which is the green in this case for D1, and I draw a right-angled triangle. And it doesn't matter where you draw the right-angled triangle. It could be down, see where my mouse is following down at the bottom. It could be there, but then when you find your components, you use 60 degrees. Okay? But I'm closing in the 30-degree angle, because this is the 30-degree angle right in here. And same thing over here, I'm closing in the 40-degree angle. So this 10 refers to the magnitude of this vector, right? It's 10 meters, 30 degrees east of north. Okay, so y is always up and down, x is always side to side. That's really important. Okay, x is always horizontal, side to side, y is always up, down. And, for steps 3, 4, and 5 then, I say, just using this idea, the ratios, that d1x over, opposite, this is opposite the angle. So opposite over hypotenuse equals sine of the angle, and that's where I'm getting this from. And I'm sort of assuming now that you know that, and I'm jumping into calling my angles like such, because this would say d1x then equals 10 times that. Okay? So step 3, 4, and 5 is you name each component, each horizontal and each vertical component, where x is horizontal, y is vertical, in terms of sine and cosine. Okay? So hopefully you can see where I got all those. Just put a little star beside something if you're not following where it's coming from or why, but the big thing is that I use sine if it's opposite, not touching the angle. It's directly across, opposite. I use cosine if it's touching the angle. So y here is touching my angle, right? d2y, so it's got to be cosine. And like adjacent means touching the angle for cosine. The other thing is, once you've figured out, if I'm looking at d1, once I figured out that it's sine, it's automatic that y is cosine. You can't really screw that up, okay? That would apply all the time. Step number 6, just make sure you have the right sign on the horizontal and vertical components. So if I say that north and east are positive, this is, d1y is north and d1x is east, right? So it's all good to go. They're both positive. However, so these are both positive. This one, however, the y component is north, which is positive, but the x component is west, so it should be a negative number. Okay, so you make that negative, and that's step number 6. Done. Okay, by putting that negative right there. Now you can evaluate these, put them in your calculator and figure out what 10 times sine 30, which is 5, but you could do that if you wanted to. I think it's better to hold on to using your calculator till you absolutely have to. It basically holds significant digits and makes it more accurate. And I think it makes the answer a little cleaner too. So moving on to step number 7 then, you find the overall displacement in the x direction, which is adding the d1x and d2x. So just notice d1x is positive, but d2x is negative. And so since it's negative, I put a negative right there. Even though I'm adding the vectors, it's like adding a negative number, right? So this ends up to minus approximately, little dot on top, approximately minus 7.86. So now I've put it in my calculator and I've lost accuracy in my solution as soon as you do that. Similarly over here, my overall change in y is d1y plus d2y, and in this case they're both positives, so I just add and I get this big number. Okay. Step number 9, make a right angled triangle. So here's my horizontal, and what you do, just to be very, very clear on how you do this, dx is in the negative direction, which is west. dy is in the positive direction, which is north. You put your pencil down, you draw the horizontal, you do not pick up your pencil, you keep your pencil connected, and you draw the vertical. Okay, so I drew the 7.86 in the negative direction. I no longer need to use a negative in the number because it's implied by the fact that it's in the negative direction. Okay, so at this point, from this point on in the solution, don't use any negatives. Again, you could draw either one first, but just for practice, just be consistency's sake, draw the horizontal first, don't pick up your pencil, draw the vertical. Okay, and then your overall delta D is from where you started drawing to where you finished drawing. Okay, and the angle you're looking at is the enclosed angle that's close to where you start. Okay, close to where you start. So then step 10, use Pythagorean theorem to solve for your overall delta D. So it's just the hypotenuse of this triangle, right? This is a right angle triangle. I'm going to solve for the hypotenuse, just using Pythagorean theorem. And then I'm going to solve for that angle using tangent, where this is opposite and this is adjacent. Okay? So sub in the numbers, and you can see the answer come out. Always good to practice along with me, by the way, and do the question yourself. So I know it's north of west because this is west and my angle is 72 degrees, so my vector is 72 degrees away from that. Okay? Now the last step to my problem is to say, does this answer make sense? And so what I want to do for that is to look back to my first drawing. And does this number look like it makes sense with respect to what I first thought it should be? And if we go back to the very beginning here, so the answer is 25, which is bigger than either of these. And so that looks about right, and 72 degrees north of west. And I would say that looks about right. So even though this is just my first guess, it gives me an idea if my answer is reasonable or not. And heck yes, it's reasonable. So I'm going to put a check mark on there. Good answer, Ms. Stone. And done. Question done. That's a long example. Again, take time to review it again if you get stuck on one of the steps, but yeah. That's vector addition using using x and y components.